Right now we have a circuit where the RGB LED smoothly fades in and out after power up. In this episode we will add a slide switch to toggle between simple blinking and smooth fading modes. Let's start with the hardware. First, we add a slide switch and connect it to the VCC and to pin 3 of the MCU. Next, we add a 10K pull-down resistor. We connect it between the switch and the MCU pin, with the other side going to the ground. And that's the entire wiring. Before moving on, there is one issue worth showing. When switching between modes, I was getting a small glitch, a brief flash on the LED. It only happened at the moment of switching, even though everything else was working correctly. The reason is how fast PWM behaves near zero. It doesn't always produce a perfect clean off state, so when the mode changes, a short unintended pulse can appear. At least I think so. I'm not quite sure. To fix this, I switched to phase correct PWM, which handles the transition around zero most symmetrically and avoid the glitch. As you can see, the switching is not immediate, and that's intentional. I designed it this way to keep the behavior simple and smooth. Immediate switching could introduce a lot of problems. I would need to deal with switch bouncing, rapid user input, and carefully synchronize all timers and states. With this approach, none of this really matters. The system just waits for a neutral transition point and everything stays stable. In this case, fast reaction to the switch isn't necessary. So this solution is much cleaner and more reliable. Okay, now we can add a switching to our program. Here we define the input register and the pin used for the mode switch. Read pin B points to pin B, which is the register we use to read the actual logic level present on the port B pin. SW mode in B selects pin PB4, so this is the pin where the slide switch is connected. In other words, these two lines tell the program where to look when checking the switch position. I will change comment here because we will no longer use fast PWM, instead we will use phase correct PWM. To use phase correct PWM, we only need set WGM00 to 1, so we can remove the WGM01, and I will change the comment to the phase correct PWM, and we can remove this line because we won't need this anymore. Okay, now let's move on to the PWM tick init function. Here I configure the switch pin as an input. First, I clear the corresponding bit in the direction register, which sets the pin as an input. Then I clear the same bit in the port register to make sure the internal pull-up resistor is disabled, since we already added an external pull-down resistor in hardware. The pin will stay at a stable low level when the switch is open, and go high only when it's connected to the VCC. I'm gonna change the comment right here because we use phase correct PWM. Now I have to change this. In fast PWM I handled it differently. At zero brightness I disconnected PWM and forced the pin low manually, so the timer didn't have to drive the output all the time. Now I keep the pin in PWM mode continuously, so the timer has to control the output directly all the time. That's why mask out PWM is required. Without it, the PWM signal would only run inside the timer and wouldn't reach the LED. Now let's move to the brightness set function. I will change whole function. I will insert the mode switching logic in here. The key idea is that I only change mode when the LED is fully off, so when the brightness equals 0. This guarantees smooth transitions and avoid glitches, because I'm not interrupting the signal when the LED is on. At that moment, I read the state of the switch and decide which mode should be active. If the desired mode is different from the current one, I reinitialize the responding engine, either blink or fade. This way I don't need to worry about switch bounce, fast user input, or synchronizing timers. Everything happens at a clean, predictable point in time. Now I'm gonna move this part because it shouldn't be here. It should be where our variables are. Now let's move to the blink set function. First, let's remove the clear and save functions because I think we don't need them anymore. And we will replace the brightness set 0 with reg duty equals 0. Next, in the fade set function, I will also remove these two functions and delete this line because I will set the mode in the brightness function, so I don't need it right here again. I'm gonna change the fade phase to fade hold low because I want this function to start from the low state. And I'm gonna change the brightness set fade brightness to the reg duty fade brightness. And the one last thing I have to modify is the main function. So let's go there. I'm gonna remove this say function. I wanna replace this because on the start of the device I wanna check the state of the switch, so the device will start with the right mode, the blinking or fading. And now we can build our program. As you can see, we got an error. We get this error because we have wrong order of the functions. First we have the brightness function, and inside this function we have blink set function and fade set function, but they are declared after this function, so the compiler don't know what to do. To fix this, I will just move the brightness function from here to the place where it is after the blink and fade function. And now we can build our program and everything is okay. And now we can upload this into our MCU. Let's see now how this works. Now we have the switch off, so device should start with the blinking. Let's turn on. And yes, LED is blinking. Now let's turn off. Flip the switch. Now it should start with fading. Turn on. And yes, LED is fading and out. Now, when it is working, flip the switch and wait after it is LED is off, and it switched to the blinking. Now let's flip the switch again, and it changed to the fade in. So you can see everything works great. In the next video we will add switch to stop the blinking.